total probability theorem or law of total probability. Let S be the sample space. E1, E2, E3, and so on, En are n mutually exclusive and exhaustive events associated with a random experiment. If A is any event which occur either with E1 or E2 or E3 and so on En, then probability of A we can write as probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 and so on, probability of En into probability of A given En. That is in sigma notation, probability of A equal to sigma I equal to 1 to n, probability of Ei into probability of A given Ea. Now, how to derive this is, because S is a sample space, so I can take S as a sample space and E1, E2, E3 and so on En. I can divide the entire region into n parts such that and sum of all the parts becomes the entire sample space, and the intersection of any two or any three and so on must be a null set because they are mutually exclusive and exhaustive. So events are mutually exhaustive means the union must be the entire set, that is E1 union, E2 union and so on En must be the entire sample space, and mutually exclusive means the intersection of any two or any three and so on must be a null set. That is Ei intersection Ej is a null set, I not equal j for all I and j. Now the event A can be written as A intersection S and replace S with E1 union E2 and so on union En. Apply the distributive property. Then A will be same as A intersection E1 union A intersection E2 union and so on A intersection En. Now if I observe the events A intersection E1, this portion, A intersection E2 is this portion and so on, these events are also mutually exclusive. So the probability of the event A will become the sum of the probabilities because A intersection E1, A intersection E2 are also mutually exclusive. So probability of A intersection E1 plus probability of A intersection E2 and so on, probability of A intersection En. Now using the conditional probability, we can write as probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 and so on, probability of En into probability of A given En. So in sigma notation, probability of A equal to sigma I equal to 1 to n, P of Ei into P of A given Ei. Now, write a note here. P of E1, P of E2 and so on, P of En are called priori probabilities. Priori probabilities. That is, these probabilities are known well in advance. That's why these are called priori probabilities. And probability of A given E1, probability of A given E2 and so on are called likelihood probabilities. Likelihood probabilities. That is how likely the event A occur under the condition that the event E1 is occur, or how likely the event A occur under the condition that E2 is occurred already. That's why these are called the likelihood probabilities. So one problem for the total probability theorem is, there are two bags. First bag contains 5 white and 3 black balls, and the second bag contains 3 white and 5 black balls. Now we have to draw 2 balls randomly from the first bag and are put into the second bag. After that, 2 balls drawn from the second bag, then what the probability of getting 2 balls from the second bag such that one is white and another is black. That means here you will be having 3 cases. That means you can have 3 events, E1, E2, E3. E1 can be defined as selection of 2 white balls from bag B1. E2 can be defined as selection of 1 white and 1 black ball from bag B1. and E3 is defined as selection of 2 black balls from bag 1. And the event A can be defined as selection of 2 balls from bag 2 such that one is white and another is black. Now the corresponding probabilities are P of E1, means we are selecting 2 white balls from bag 1. Now 2 white balls means 5C2 upon total is what? 8. So 5C2 upon 8C2. Probability of E2, that is 1 white and 1 black. 5C1 into 3C1 upon 8C2. Probability of E3, 2 black balls from bag 1. That means 3C2 upon 8C2. Next, probability of A given E1 means after the event E1 occur, then what is the probability of occurring of event A? That means E1 is occurred means we have transferred 2 white balls from bag 1 to bag 2. After that, we are selecting 2 balls from bag 2 such that 1 white and 1 black. Now, when E1 is occurred means because we have transferred 2 white balls, so in the bag 2, the number of white balls will be 5 and number of black balls also will be 5. And now we need to select 1 white and 1 black. So it will be 5C1 into 5C1 upon 10C2. Probability of A given E2. That means E2 is occur. E2 is occur means 1 white and 1 black ball we have transferred to B2. Then the number of white in the bag 2 will be 4 and number of black balls will be in the 6. Then selection of 2 balls, 1 white and 1 black. It will be 4C1 into 6C1 upon 10C2. In the same manner, probability of A given E3 will be 3C1 into 7C1 upon 10C2. Now total probability, that is probability of A equal to sigma equal to 1 to 3, probability of EI into probability of A given EI. So if you substitute and simplify, you will find 673 upon 1260. Bayes theorem. Let S be a sample space. E1, E2, E3, and so on, En are n events which are mutually exclusive and exhaustive events associated with a random experiment. If A, B, any event occur with either E1 or E2 or E3 and so on En, then probability of EI given A is probability of EI into probability of A given EI upon sigma equal to 1 to n probability of EI into probability of A given EI, I equal to 1 to n. This is almost similar to the previous one, total probability theorem. That means entire derivation, that total probability theorem will be part of it. So here S is a sample space, E1 to En are mutually exclusive and exhaustive events. Then previously we have derived a probability of A as sigma equal to 1 to n P of EI into P of A given EI. Now P of EI given A, using the conditional probability, we can write as P of EI intersection A upon P of A. Now again using multiplication theorem of probability, P of EI into P of A given EI upon P of A. And now replace P of A with sigma equal to 1 to n P of EI into P of A given EI, where I equal to 1 to n. So here P of E1, P of E2 and so on, P of En are called priori probabilities, and P of A given E1, A given E2 and so on are called likelihood probabilities. That is after the happening of the event E1, E2, E3 and so on En, but the chance of occurring the event A. Next, probability of E1 given A, E2 given A and so on are called posterior probabilities. That these probabilities are known after the experiment is over. That is, what is the chance of occurring the event A when A is occurred. Now, so there are 3 urns. So the first urn contains 6 red and 4 white black balls. Second urn contains 4 red, 6 black balls. And third urn contains 5 red and 5 black balls. Now one urn is selected at random and a ball is drawn from it. Now ball drawn must be a red. Find the probability that it is drawn from the first urn. Now here we can define 3 events E1 to E3 as E1 is selection of first urn, E2 is selection of second urn, and E3 is selection of the third urn. And the event A can be defined as red ball selected from an urn. Now A given E1 means after the urn 1 selected, then selection of a red ball from urn 1, which is red ball selected from urn 1. In the same manner, A given E2, A given E3. Now E1 given A, when selected red ball is from first on. Now, as per the question, we need to calculate probability of E1 given A. So, probability of E1 is same as probability of E2 is same as probability of E3 equal 1 by 3 and probability of A given E1. That is when on one selected, then was the probability of getting a red ball. That is 6 upon 10. Probability of A given E2, 4 upon 10. Probability of A given E3, 5 upon 10. Probability of A, sigma equal 1 to 3 P of A into P of A given A, which is 1 by 2. Next, probability of E1 given A equal probability of E1, probability of A given E1 upon sigma equal 1 to 3 P of E1 into P of A given E1, which is 2 by